A block of mass 3.6 kilograms is placed on a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction between the block and the plane is 0.2. A force of 30 newtons parallel to the line of the greatest slope of the plane pulls the block up the plane from rest. A. Calculate the acceleration of the block. After 4 seconds, the 30 Newton force is removed. Calculate the total distance the block travels before coming to rest again. Okay, essential to draw a diagram. So you put a block which is at an angle of 30 degrees. The forces acting on the block will be the 3.6 G Newton weight, the resistance, and a 30 Newton force pulling it up the plane. And because it's rough, then there will be a friction here, mu r, and don't forget to mark on the acceleration. Right, if we resolve perpendicular to the plane, because we will need to find mu r, which is the frictional force, then we have r, and then the component of the weight will be this one, which will be 3.6 g cos of 30 degrees is equal to 0, because that's in equilibrium, and that will give that r is 3.6 g cos 30. Resolving along the plane, we can have 30 newtons minus mu r and minus the component of the weight here, so that's going to be 3.6 g sine of this angle, which is 30 degrees. And that's going to be equal to mass times acceleration, so it's going to be 3.6 times a. So we've got our value of r here, and we know that mu is 0.2 from the question. So we've got 30 minus 0.2 times 3.6 g cos 30 degrees minus 3.6 g sine 30 is equal to 3.6a. So writing that out again. And then to find a, we take all of this and divide it by 3.6. So making sure your calculator is in degree mode, use the fraction button. You can write this in just as it is written. That will give 1.7359, which is 1.74 meters per second squared. B, in the first 4 seconds, the acceleration will be this. It goes from rest, so this bit here will be 0. So the distance travelled will be a half times the acceleration times the time squared, which will be 13.887 meters. We will also need to find the velocity at the end of the 4-second period using v is equal to u plus at. U is 0, so we're going to have 1.7359 times 4, which gives 6.9436 meters per second. Right, when the Furton force is removed, the diagram becomes this. So the friction, which the constant will act downwards, okay, there'll be no force here, there'll be weight acting against it, and there'll be an r, and there'll be a new acceleration. So if we resolve along the plane here, we've got nothing going this way, so we've got minus 3.6 g sine 30, which is the weight component acting against it going up, minus mu r, because that's acting against it, is equal to mass times acceleration. So 3.6 g sine 30 minus 0.2 times r, which is 3.6 g cos 30, that won't change from before, is equal to 3.6a. And therefore a will be all of this divided by 3.6, which will give me minus 6.5974. So it's going to, acceleration is going to act against it, and it's going to slow the block down, which we would expect. So if we now use v squared is equal to u squared plus 2as to find s, we want the final velocity to be 0. The initial velocity will be here will be the velocity we found when the force is removed, which is this value, plus 2 times my acceleration times s. Rearrange to find s, so it'll be 6.9436 squared divided by 2 times minus 6.594 we'll need to put a minus sign here, and that will give you 3.6539 meters. Okay, so we need to add the two distances together, so the total distance will be the distance travelled in the first 4 seconds, which is 13.887, plus the distance travelled in the once the force has been removed, giving a total distance of 17.5 meters, correct to 3 significant figures. Okay, so this has been a video to show you that the distance of a block moving up a rough plane. I hope you've understood, and I thank you very much for watching.